Another common function that we're going to talk about in Chapter 1 is quadratics. Again, quadratic is something you should have seen many times in your algebra history, in your math history. Quadratic, you should have been talked about how to factor quadratics, quadratic equations, solving quadratics, graphs of quadratics. We're going to hit the basics, and we're going to stick to solving using the graphing calculator. We're not going to go through, we don't have time to go through all of those other methods that you should have seen. If you want to use one of the other methods, the factoring method, quadratic formula, and all of those, feel free. We're going to keep it basic here, and we're going to use our graphing calculator for the most part. Right, so quadratics are whenever I have a square term, an x term, or a constant term put together, and I at least need the square term. All right, I might not have the x term, and I might not have the constant term, but I have at very least a square term. And so, you know, usually the generic format is for, I have a quadratic is ax squared plus bx plus c as long as a does not equal 0. All right, that's the standard form for a quadratic function, where a, b, and c are, again, numbers. So I have to have at least a square term to be a quadratic. I might have an x term, I might have a constant term, but I don't have to. All right, in order to be a quadratic, all I have to have is that term. Alright, so a simple example was my g of x function here. X squared minus 3x minus 4. Alright, whenever we're dealing with quadratics, the graphs are always parabolas. Alright, parabolas, they either open up or they open down, and it's the square terms that tell me. If the square term's positive, it's a parabola that opens up. If the square term was negative, it would be a parabola that was opening down. This particular function, the square term's positive, and so it's opening up. Quadratics, the domain is always all reals, so negative infinity to positive infinity, or you can say all reals. I can plug anything I want into it that makes it true. Alright, so we're going to graph my x squared minus 3x minus 4, and we're going to find the vertex of the parabola. It's either a max or the min point on my graph, depending on how the parabola opens. In this case, it's going to be a min because it opens up. I'm going to find a numerical table of solutions. I'm going to graph the function, determine its domain and range. Again, we will do the calculator. There are by-hand algebraic methods. We're not going to do the by-hand algebraic methods. We just don't have time to do the algebraic methods. We're going to stick to using the calculator. All right, you get to use it no matter what. All right, so first, I'm going to do a numerical table. All right, so my numerical table, which means I just want to pick some table values I'm going to plot. Always a good idea to pick positive and negative values, just kind of see how it lands. So I'm just going to hit -1, 0, +1. Maybe 2 to give me a fairly good shape. Alright, so I'm plugging them into this function, g of x. So when I plug -1 in, I get 0 out. When I plug 0 in, I get -4 out. When I plug 1 in, -6. And when I plug 2 in, I also get -6. Alright, so there's some table examples. Now we're going to graph it. Alright, I'm going to plot those points, and then I'm actually going to go to the graphing calculator and double check to make sure everything looks the way it should. So there's my y-axis, there's my x-axis, so -1, 0, so it puts me there. 1, 2, 3, 4, 5. Oops, I need to give myself a little more space going down. Alright, -1, 0 puts me here. 0, 1, 2, 3, 4 puts me there. 1, 6 puts me there. Oops. 2, 6 puts me there. Alright, I'm going to assume the parabola is opening, and so the vertex is somewhere between these 2 points. Now I'm going to go and double check that on my calculator. So I'm going to pop up my calculator here and I'm going to plug it in. Alright, so I'm going to go here, clear anything else I had in there, type in my x squared minus 3x minus 4, zoom standard 6, and see what it looks like. Alright, so there is sort of the shape. So now I'm going to go and kind of, so it comes down through these points. Somewhere between there is my vertex. See if I can see where it crosses at 4. 1, 2, 3, 4. And there's g of x. Alright, so there's a parabola opening up. Alright, so somewhere between those 2 points is the vertex, which I'm going to find. There is a by hand method. It's to find the x value. It's the opposite of b over 2a. And if you want to use the vertex equation and solve for the vertex that way, I'm going to use my graphing calculator. Alright, so I'm going to use the graphing calculator to find my vertex. In this case, the vertex is a minimum. Because it's again, the smallest point on my entire graph, right? It's a minimum, smallest point on my entire graph. Okay, so where we go to the calculator, well, there's a way to do that on the calculator. Where it's found, if you have a TI-84, 83, any calculations on the calculator is always found under second trace. So you hit the second button, then trace, and then you've got value, 0, min, max. All right, I want to find my minimum, so I select 3. Then the calculator is going to run through a program. So it asks you to do some things. It asks you to go to the left of your minimum, which I'm already to the left, but I like to get a little closer just because it'll go faster if I get a little closer. But I want to make sure I stay to the left of where it looks like the minimum is. Hit enter, and then I scroll over, and I want to go to the right. And again, I make sure I pass it, and I go all the way to the right side. Hit enter, and then they ask you to guess, and the guess just is, if you can guess fairly accurately, the calculator will find it faster. Alright, so somewhere in the middle is my guess. Alright, so the calculator is a little flawed. It is actually at 1.5. Now, you should be logical to round there, right? 1.499999999 would round to 1.5. The y value is correct at negative 6.25. Alright, so my vertex is at negative 1.5, 6.25. Alright, that's the minimum value on my function. Which I need that in order to find my range. Now, my domain I don't. My range I do. Alright, so what is the domain? Well, the domain for all quadratics is all real numbers. So domain is all reals, which means negative infinity to positive infinity. My range, however, is the y values. Alright, which is not all reals. It's what I needed my minimum for, right? My minimum y value was at this point negative 1.5, 6.2, and the y value is the 6.5. So the smallest y value, the minimum y value, is 6.25, and then it shoots up to infinity on both sides of that minimum. And so the range, the y values, the function values possible out of this function are 6.25 and anything bigger than it. I can't go below 6.25, it's the smallest. And so my range is 6.25 to infinity. We include 6.25, so remember, brackets include, parentheses exclude. Alright, so brackets is what we want. Alright, next example, g of 2. Well, let's just plug my x value of 2 in and find what my y value is. And this one I'm just going to use the calculator, so 2, and plug it into my equation. So remember, I'm going to go plug it in to this equation, so it's going to be 2 squared minus 3 times 2 minus 4, which I already found earlier, which was negative 6. Right, that was the y value, the unique y value that come out. When I plug 2 in, I get negative 6 out. Alright, the harder case is when I'm asked for the x values. Right, I know I want the y value 6. What are the x values that I plugged to find 6? And so again, there is a by hand method. We aren't going to solve using the by hand method. We're going to solve using the calculator method. Right, which means I'm going to graph my y value. So I'm going to go into my calculator and I'm going to graph this. So I'm going to go back to my calculator. I'm going to hit graph, some y equals, and then I'm going to leave my parabola, x squared minus 3x minus 4 there. And underneath it, in a new y2, I'm going to plug in my y value 6. So y equals 6. There's the y equals 6. Hit graph, and then what it does is there's my line, y equals 6. So what it does is it goes and graphs. So it graphs a line, y equals 6. And what we want to find is, well, when is the quadratic y equals 6? So I've got to find these x values. Well, we do that graphically. We want to know where the y equals 6 and my parabola intersect, right? That's what we're finding. And so when we solve this graphically, we're going to find where they intersect. On the calculator, same place that we did the minimum. So you go second, trace, if you'll see, under max and min, there's the word intersect. So I want to find the points where they intersect. So I select 5. And then again, the calculator's got to program it. I'm on my first curve, which on my parabola, I've got to get as close as I can to that moment. So I go over, and I get as close as I can. I went too far. Alright, that looks close. And now I should be on the second curve. I should be on the line. It's pretty close. Enter, and then guess. As long as I'm close and I don't have to move it again, I hit enter. And so at -2, and then I do the same thing for the other one. So I'm going to do the exact same thing on the other side. So -2 is one answer. And then do the same thing. So now I've got to scroll all the way over to the other side. Calculator's program is slow. Just too far. Right, close enough. Second curve, and then guess. So usually if I'm close enough, I just hit my button 3 times. And so the other value is 5. And so where it intersects, actually I didn't have to do an approximate, it's exactly at 5 and exactly at -2. So -2 there, exactly at 5. And there's my solution. Alright, so the x value, so there's 2 answers, -2 and 5. That means if I take G, plug -2, I should get 6 out. And when I take G, I plug 5 in, I should also get 6 out. And that is true. When I plug -2 in, I get 6 out. So you can always kind of check your answer. That's my answer. This is the answer. And then the check is, well, when I plug -2, do I get 6 out? When I plug in +5, do I get 6 out? And so yes, those do both check. All right, the last one. Alright, f of t squared minus 4. So the first is just finding f of 0. So 0 is the t value. So 0 squared minus 4. So f of 0 is -4. And then f of -2. Always be careful with negatives. I'm plugging -2 in, and I'm squaring it. So remember, that's going to come out of +4. And so it's 4 minus 4, which is 0. So f of -2 is 0. Graph the function. You can use a graphing tool or plotting points. This one actually is it's the x squared function shifted down 4 units. So if I plug 0 in, I get -4 out. So that's the vertex. And then it goes over. And again, you can graph it however you want. You can I would suggest using a graphing calculator and picking some points on both sides. So 0, -4 would be its minimum. Right, this would be the vertex. And then it also goes through 2, 0, and -2, 0. Right, and there's the graph of the function. So we're going to do an application of quadratics later on, but like I said, we're going to do most everything on the graphing calculator. So as long as you can find stuff on the graphing calculator, alright, we're not going to get into any, we're not going to do the quadratic formula, factoring, or any of that stuff, although that stuff is all fine, and if you remember how to do it, feel free to do that. We're just going to keep it fairly simple with quadratics. We're going to do everything graphically, everything using the graphing calculator. Alright, the last thing, so the next video, the last thing from this particular section is we're going to look at applications, and there's 3 types of applications we can do. Applications where we get a set of numbers, numerical case. Application where we get a graphical case, or an application where they give us a function, which we'll do in a quadratic case, because we're going to get to linear cases in the next 2 sections. So I'm going to hit a quadratic case here in this section. Alright, so we'll stop there.